let's talk about the range of a function. Now, just like with our discussion with the domain, we're dealing with real valued functions here, right? So our domain and range only consist of real numbers. Okay, let's have an example. So let's have y equals, or let me use f of x. So f of x equals x squared plus 1. And then we're asked to find the range of this function. So to find the range, we need to find the domain first. Okay, so the domain, again, the domain is the set of all numbers that will give us a valid output, right? But then by inspection, you can see that any number that you substitute for x will give you a real number, right? And so any number that you take as input will give you a valid output. And that means that your domain is the set of real numbers. Okay, so meaning any real number will give you a valid output. Okay, so now let's find the range for this function. Now, what is the range, by the way? Okay, so the range is the set of all possible outputs based on your domain. Okay, so here our domain is R. So meaning that if we plug in all real numbers into our function and we list all those outputs, that will make up our range. Okay, so but then that's impossible, right? We can't try all the numbers and list down all the outputs. We can't do that. Okay, so instead of doing that, we can just make a simple argument. We can just say that since if you plug in a real number for x and then you square that number, you will only get a positive result, positive or 0, right? So that means that for this term right here, you will only get numbers from 0 to infinity. You will not get numbers less than 0, okay, for this term. And then all that's left to do is you add 1. Okay, so you're gonna add 1 to your smallest and biggest number in your set. So that means that 0 plus 1 will give you 1. Infinity plus 1 will give you infinity. So your range will be from 1 to infinity. That's it. Or you can write it in another way. You can write it as y, such that y is greater than or equal to 1. That's the same thing. So that's how you find the range. Now there's another way of finding the range. Let me erase this one. And so to use that method, you need to rewrite this as an equation. You need to replace f of x with y. So y equals x squared plus 1. And then all you need to do is invert the function. So instead of having y as your isolated variable, you will have it as x. Okay, so you need to isolate x instead of y. Okay, so to isolate x, so we're going to have y minus 1 equals x squared. And then to get rid of that squared, you take the square root of both sides. Don't forget plus minus. So you'll get x equals plus minus square root of y minus 1. And then what you're going to do is try to find the values of y that will give a valid output. So basically, y will be your new input and x will be your new output. Okay, for this one. So what values of y will give valid outputs? Okay, so remember that this thing inside the radical sign should be greater than or equal to 0. You can't have a number right here that is less than 0. That will make it a complex number, right? That will give us an invalid output. So y cannot be less than 1. Okay, so y cannot be less than 1. 1 is the smallest number for y. In fact, if y is 1, we'll get 1 minus 1, that's 0. Square root of 0 is 0. That's the smallest number that you can substitute for y. If you make it say 0, so if y is 0, you'll get 0 minus 1, you'll get negative 1. Square root of negative 1 is a complex number. Okay, So therefore y should only be greater than or equal to 1 for this expression to have to be valid, right? So that's y is greater than 1. That's exactly what we got right here. Okay, so that's another way of looking at it.